Alright, get ready because this is video 213. That is Unit 2, Standard 1, Video 3. We're still talking about graphing and identifying key characteristics of linear and piecewise functions. And we're going to be talking in this video about rate of change. Pause the video, make sure you've got that written down at the top of your paper, and then we'll proceed. Alright, here we go. So we're going to start with what is the definition of rate of change? Well, rate is talking about something happening over a period of time, perhaps, but it is comparing two values. It's a rate. We talk about price per item, that's a rate. And maybe that price per item will increase. Maybe we talk about the population over time, so it is the population growth rate. We might be talking about interest rates. Those are a little bit different, but if we are comparing a rate that changes, because we are talking about a rate of change here, then we can correlate it back. So in that case, we might not always use the example of like interest rates for this particular topic, but defining rate of change means that we're looking for a way to define the change in the y values compared to the change in the x values. Oop, I don't know what I got going on there. That's a V. Values. I can't spell values. It's terrible enough I'm going to erase it. Alright. So, our change in y values divided by the change in the x values. This can be written a few ways. We also write in mathematics, we use the triangle. The triangle is a delta. It's a Greek symbol, but in mathematics, delta means change. So we could say delta y over delta x. Okay, we often calculate change using subtraction. So we can subtract the y's and subtract the x's. Now this might sound familiar because it is slope. Okay, so we talk about slope as in the vertical change, and in Algebra 1 you may have talked about this using the word rise, and we compare that to the horizontal change, which you may have called run. Okay, so all of these things are the same. We're looking at a vertical change compared to its horizontal change, kind of like climbing stairs. You actually also did this when you were looking at right triangles. So there's lots of mathematical connections to rate of change. But since we are heading towards going to calculus one day, whether we take it here at Schaumburg or we take it at a college or university, we will not use the word slope very often in this class. We will be talking about the rate of change. It is a word that gets applied, or a concept that gets applied to lots more than just lines, and so we want to be able to use the correct vocabulary as we move forward. So we will be talking about the change in y over the change in x, or the vertical change over the horizontal change, or delta y over delta x, or just plain old rate of change. Does it mean slope? Yes, it does, but slope is very specific to lines, and we'll be working with functions that are not linear. So, moving forward, how do we calculate the rate of change? Well, I kind of hinted at it. We're going to be subtracting the y's and subtracting the x's. So let's just throw out a couple ordered pairs there. So if I have the ordered pair -2, 5, and I have the next ordered pair of 3, 7, and I said, what is the rate of change between those two? That we would go ahead and subtract the y's first. So maybe I would do 7 minus 5 over 3 minus a -2. This gives me 2 over 5, or 2/5. So this, we do not want to necessarily put this into a decimal. We'd want to leave it as a fraction because it does tell us that for every 2 we move up, we must move over 5. Okay, let's go ahead and try another set. What if we did 6, 1, and we did 0, -3. Okay, let's take a look at that one. So this one leads us with subtracting the y's. Now, in this case, I'm going to use these first. So I'm going to subtract this way, and that's going to give me 1 minus -3 over 6 minus 0, it won't make a difference. This still ends up with 4 over 6. This can be reduced to 2 over 3. So for every 2 we move up, we move to the right 3. So that is our rate of change, our vertical change over our horizontal change. Okay, and then how about if I propose it like this? What if I said f of 3 equals 7 and f of negative 1 equals negative 2? Okay, so I did give you ordered pairs here. I did give you x values and I did give you y values. The x's are written inside of the parentheses and the y's are the outcome. So if I use those, again, subtracting my y's would be negative 2 minus 7, negative 1 minus 3. That gives me negative 9 over negative 4. The negatives would cancel, and it's 9/4. That means for every 9 we go up, we move over 4 to the right, calculating the rate of change. Now we also may need to interpret our rate of change. And interpreting the rate of change may just mean that we're going to be taking a look at, over a period of time, how does how do numbers change? So here's an example. In 1997, the sale, this may sound like an old problem because it totally is, the sale of VCRs, yes, those things existed in 1997, okay, were 16.7 million. Okay, in 2002, the sales of VCRs were down a little bit. They were 13.3 million. So if we needed to find the rate of change of the sales of VCR, so the average rate of change of VCR sales, so that's our direction, find the rate of change of VCR sales between 1997 and 2002. Now the reason I'm saying we are looking definitely between these two dates is because I don't have any other information. Maybe the rate of change in other areas or in other years is not going to be the same here. I only have this small piece of information, so I can only report out on this small piece of information. So what are my x's and what are my y's? Well, time is always our independent variable. So that means that I would have my independent variable 1997, comma 16.7, and then 2002, comma 13.3. And we would go ahead and use subtraction. So this would mean if I did 16.7 minus 13.3, and I have to keep them going in the same way. So if I did 16.7 minus 13.3, I have to do 1997 minus 2002. And this leaves me with positive 3.4 over a negative 5, which then calculates, and in this case, because I am looking for an application problem, it's a real life problem, I could say that they were down 3.4 million for every 5 years. Okay, that would make sense. Or, so let me write that out. Sales went down 3.4 million over 5 years. Or we could say, if I actually did the division here, it would be, division would be negative 0.68. So that would be, or down 0.68, get that right, Miss Moran, 0.68 each year from 1997 to 2002. Okay, so I gave you a lot of information here. All right, if I wanted to talk about 3.4 million over 5 years, I used the word down instead of using the negative. Okay, then I said, well, it also went down 0.6h each year between these years. So that's actually probably more informative to us because I want to know about each year, not this general 5-year thing. So here we are interpreting the use of rate of change. All right, so if you want to go back and review anything, please do. If you've got some comments or questions, please post them on Schoology and make sure you try the entrance slip as well.